Dear students, in today's session I am going to talk about electrochemistry, which is a part of module 1, first topic, which consists of two parts. First topic is electrochemistry and the second part is corrosion. So let us start the topic corrosion. So these are some of the keywords in this topic. That is, I am going to give you an introduction regarding electrochemistry, which you have studied in the previous class. Then we will talk about what are the electrolytes, what are the different types of electrolytes, and their definition in order to understand the electrochemistry clearly. And the second one is electrode potential, which we are going to determine, and we will study the methods to determine this by using standard electrodes such as hydrogen electrode and calomel electrode. We will also study about how to construct a hydrogen electrode, how it works, and how you can determine the electrode potential. Similarly, we will also study about construction of calomel electrode and how it can be used for the determination of electrode potential. So let us start. The first one, that is introduction. As you already studied in your lower class, what is electrochemistry? So electrochemistry is nothing but we will study about the change of electrical energy into chemical energy. Similarly, by using chemical energy, we can produce electrical energy. These two processes you have to study in electrochemistry. In your intermediate, you have already studied electrochemistry, where you have studied about what are the different types of electrolytes. Similarly, Faraday's law, Faraday's first law and Faraday's second law, which will tell us about how much quantity of electricity you have to produce in order to get some weight of the metal deposited during electrolysis. Similarly, you have also studied about second law, where you will study about the weight deposited by different electrolytes will depend upon their equivalent weights. Like that you have studied in your lower classes. So in this class, again we will start from the basics. That is, what is the difference between a metallic conductor and an electrolytic conductor? As you all know, the metallic conductors will conduct electricity at a greater extent than the electrolytes. So what is the difference, or what might be the reason for this, we will study. So let us see what are the metallic conductors. Metallic conductors, they flow electricity without decomposition of the metal. We can see the metal will not undergo any change during the electrical conductivity. But in the case of electrolytes, the decomposition of the electrolyte will take place. So what is an electrolyte? The substance. We will go in detail in the later. At present, we will tell what is an electrolyte is. The substance which will dissociate to form its corresponding ions. That is, if you take NaCl, NaCl, it is an electrolyte. What it has to do? It has to decompose to give Na plus and Cl minus. These ions are responsible for the conduction of the electricity in electrolytes. That is, decomposition of the substance have to take place in order to pass electricity in the case of electrolytic conductors. But in the case of metallic conductors, there is no decomposition, there is no change in the chemical composition, but simply they will transfer the electrons. How they will transfer the electrons, how electricity will flow, you will study with the help of band theory. That is, if the valence band and the conduction band both will overlap, then we will have free electrons to move, and these are responsible for the conduction of electricity in the case of metals. Similarly, second point you say, what is that? Flow of electricity is due to flow of electrons, as just mentioned, but here the flow of electricity is due to flow of ions. It may be cation or anion. If these ions are there, those are responsible for the conductance of the conductivity in electrolytic substances. Similarly, the third point. So in the case of metallic conductors, what will happen? The conductance decreases with increase in temperature. Why? Due to vibrating of the kernel atoms, or the atoms in a metal. What will happen? They will start vibrating if you are giving thermal energy. So these vibrating atoms, what will they will do? They will interfere the flow of electrons. So since this is happening, what will happen? The flow of free electrons in a conductor will be hindered by the vibration of atoms which are present in their path. So these will offer a resistance to the moving electrons in a conductor. Understand what is happening? If there is increase in temperature, the atoms will start vibrating and they will interfere the flow of electrons. As a result, what will happen? With increasing the temperature, there is a decrease in conductance. But what about the electrolytic conductors? With increasing the temperature, what will happen? The conductance will also increases. What is the reason? Reason is, in electrolytic conductance, the conductivity is due to ions. If you increase temperature, if you increase temperature, what will happen? The ionization of the electrolytes will take place. They will start ionizing. So with increasing temperature, more number of ions will be produced and more charge carriers will be available. As a result, the conductance of the electrolytes will increases with increasing the temperature. Similarly, the resistance offered by the metals is due to ionic interactions, which we discussed just now. Similarly, in the case of these things, what will happen? It depends upon the viscosity of the solvent. If you are taking the electrolyte in a solvent which is having more viscous nature, then the movement of the ions will be hindered or it will decreases. Means conductivity will be more in those solvents where the viscosity is less. So conductance will also depends upon viscosity as well as interaction of the ions. So this is the main difference between a metallic conductor and an electrolytic conductor. And these are also, you have studied about those substances which will decrease their conductance with temperature are called ohmic conductors, means which will obey the Ohm's law are called the metallic conductors, and which do not obey the Ohm's law are called non-ohmic conductors or electrolytic conductors. Because in this case you can see, with increasing the temperature, what is happening? The resistance is also decreasing here, means conductance is increasing, but here with increasing temperature, resistance is also increasing, means conductance is decreasing. So this is the main difference between electrolytic conductors and metallic conductors. Now we will go for what are the electrolytes. So what are the electrolytes? Electrolytes are the substances which will conduct electricity either in their solution phase or in their molten state or fused state. So what are the electrolytes? You can see the definition here. Electropotential. Okay, the substances which can able to pass electricity either in their solution state or molten state are called electrolytes. So for example, if you take a pure water, what is the water? Simply, if you take a water in a container and place 2 electrodes and pass some electricity, do they conduct electricity in the case of pure water? If you take only water, there is no flow of electrons, means there are no ions and no charge carriers are there, hence it will not conduct electricity. But if you place some electrolytes like NaCl or acids like HCl, what will happen? They will start ionizing to give corresponding ions, and these ions which are present in the solution will start conducting the electricity. That is the first one, means those substances which will pass electricity in the solution are called electrolytes. Similarly, if you take any starch or glucose and dissolve in water, what will happen? They will also dissolve, they will also form a solution, but do they conduct electricity? These substances don't conduct electricity. What is the reason? Because these substances cannot produce any ions. It cannot produce ions. If there are no ions, there is no charge carriers, there will be no conductance. So these are called non-electrolytes. Means the substances which do not conduct electricity are called non-electrolytes. The substances which conduct electricity are called electrolytes in solution phase. Similarly, what is this molten state, or it is also sometimes called as fused state? So what is meant by fused state? If you take a metal like NaCl, which is generally in the form of crystals, if you put two electrons in the crystals, they don't conduct any electricity because there is a air gap present between the crystals which will hinder the flow of ions. But if you start melting these substances with the help of a flame up to 1000 degrees centigrade, you melt it, then what will happen? These crystals which are there, they start melting and form what they form? They form fused state, means they will become like a liquid. So in this fused state, at high temperatures, what will happen? Again, the availability of Na plus and Cl plus you can see. So these ions are responsible for the conductance of electricity. That is, those substances which will conduct electricity either in solution state, molten state or fused state are called electrolytes, and those substances which will not conduct electricity are called non-electrolytes. Example, starch, glucose and etc. You can see with the help of this diagram. So here it is very clear that if you are taking any solution like sucrose, glucose, fructose, whatever may be the organic substances, and you place two electrodes, what will happen? There will be no electricity and the bulb will not glow. But if you take substances like NaCl, HCl, H2SO4, like strong acids, or HCl, H2SO4, HNO3, like the strong acids or salts like KCl, NaCl, MgCl2, like that if you put in the solution, what will happen? They will undergo ionization to 100% and they will produce, that is, charge carriers, that is ions, which are responsible for the flow of electricity, and the bulb will glow at very high intensity, you can see here. But if you take electrolytes which are called weak electrolytes, then what will happen? The flow of electrons will be there due to the presence of ions, such as in this case you will get a state ion, that is CH3, COO minus and H plus ions. These two ions are responsible in the case of weak electrolyte. But why we are getting only a little amount of electricity? Because in this case what will happen? The electrolyte, that is weak electrolyte, CH3 COOH, will not ionize completely. It will ionize to only a little extent and it will produce corresponding ions. You can see here equilibrium, means it is not 100% ionizing. So these are available ions very less in number. So in this case, if you increase temperature, the equilibrium will shift towards the right hand side and the conductance will increases, which we have studied just now, the differences between metallic conductors and non-metallic conductors, how the temperature is influencing. That type of study will be facilitated by these type of electrolytes, where you can see the drastic change in conductivity with increasing the temperature of the solution. Because the equilibrium will shift, we will get more number of ions for the passage of electricity. So this is broad classification of electrolytes on the basis of their conductivity, which are non-electrolytes, strong electrolytes and weak electrolytes. Strong electrolytes will ionize completely to give their corresponding ions and will get a maximum conductance in strong electrolytes. In weak electrolytes only, for a little extent we can observe the conductance. In non-electrolytes, there is no chance of formation of ions, hence we cannot see the conductance. So this is the next one. And now we are going to study about electrode potential. So what is electrode potential? So in your lower classes you have studied about an electrolytic cell, which consists of two electrodes, and you pass current, they undergo electrolysis, and the circuit will goes on by the transfer of these electrons. So what is this? What do you mean by this electrode potential? So this is the new topic which we are going to study in engineering chemistry. This electrode potential is nothing but the potential developed when you place a metal in its salt solution. For example, you take a beaker, and in this beaker you take copper sulfate solution, and you have to immerse the copper metal, which is nothing but an electrode. This is copper metal. Then what will happen? The copper which is present in the metal will start ionizing and enters into the solution. Means some of the copper ions will undergo oxidation like this. Cu will give rise Cu plus 2 electrons. This Cu plus 2 will enter into the solution, and hence we will get a positive charge in the solution. At the same time, the liberated electrons, where they will go? They will go through the metal to the external circuit. Means the electrons are present on the metal copper. So there develops a potential between this positive charge and the negative charge which is present on the electrode. So this potential difference is called electrode potential. So now what is the electrode potential? The potential developed at the interface means between the solution and solid. The place between solution and solid is called interface. So the potential developed at the interface when a metal and its solution, that is metal, is in contact with its solution of its own ions, means copper should be placed in copper sulfate, zinc should be placed in zinc sulfate. You should not place copper in zinc sulfate solution. If you place like that, what will happen? The solution will become warmer due to the reaction, and ultimately you don't get the potential. Potential will be zero. So in this way, what we will do? We will determine the electrode potential. Another definition you can see, it is the tendency of an electrode to lose or gain of electrons when it is in contact with its own ion solution. It is also called electrode potential. So let us see how this will happen with the help of a small program. So you see that this is a solution. Into this solution we are going to immerse a metal rod. It may be copper, it may be zinc, it may be a magnesium, water may be. Then what will happen? The metal will undergo oxidation or reduction. If it is undergoing oxidation, we will call it as oxidation potential. If it is undergoing reduction, we will call it as reduction. For example, now in this case you take oxidation, that is metal in solid phase. This is S. Okay, this is the solid. This is metal in solid phase, which will ionize to give metal ions and the electrons. So electrons will be present on the metal, ions will come into the solution, as you can see. So what is happening? You are getting plus charge in the solution due to liberation of metal from the metal into its salt solution. At the same time, the electrons which are present in the electrode will acquire negative charge. So the potential difference this positive charge and the negative charge is called our electrode potential. So this is what we call electrode potential. So what is electrode potential? It is the potential developed at the interface between the metal and its salt solution. Similarly, what is called a standard electrode potential? Standard electrode potential. We have just talked about potential, but what is the difference between a standard electrode potential? As the name indicates, standards means you have to specify the conditions, such as here you should take a solution of 1 molar. What is this? This is concentration of electrolytic solution. Should be 1 molar, and temperature should be 25 degrees centigrade. If you are measuring the electrode potential at 25 degrees temperature and 1 molar solution, you are taking the salt solution, the potential developed at these conditions are called standard electrode potential. If the reaction is like this, that is metal is oxidizing, this is the oxidation reaction, then we will call it as standard oxidation potential. So if the opposite reaction is happening, that means the ions which are present in the solution are entering into the metal, then the reaction we will call it as Mn plus is reacting with the electrons which are taken from the electrode, and it is you are getting a metal S. That is, metal ions are going and they are depositing on the surface of the electrode. Then what is the reaction? Since the electrons are consumed in this reaction, this is called reduction, and the potential developed due to this reaction is called standard reduction potential. So is it clear the difference between standard oxidation potential and standard reduction potential? It is same, but the reaction was oxidation here and here it is reduction. So which is these electrode potentials are generally measured in millivolts. If in any problem, if they give you some standard reduction potential, generally we will measure standard reduction potentials like 0.013 volts. Then if you want to get oxidation potential, what you will do? You have to just change the sign. Means instead of putting negative, if you put here positive, it will become oxidation potential, because we know in a redox reaction the number of electrons transferred should be taken by another atom. So hence these two are equal, only the sign will be different. So this is regarding electrode potential. So what is electrode potential? It is the potential developed at the interface of the metal and solution when it is placed in its salt solution, means own metal ion solution. And what are standard electrode potentials? The electrode potentials which are determined at standard conditions by taking 1 molar solution of its salt solution and at a temperature of 25 degrees centigrade is called standard electrode potential. And again there are two types of standard electrode potentials, that is standard oxidation potential, standard reduction potential. If the reaction is oxidation, it is called standard oxidation potential if it is measured at these conditions. Similarly, it is called standard reduction potential if the reaction is reduction and you are measuring at these conditions. So these are the standard oxidation and reduction potentials. So next we will go for how to determine these electrode potentials. So can you measure the potential which is developed at this interface? What is my question? Can you measure the potential developed at the interface, means between the solution and the metal? Is it possible? It is not possible, because you can't measure the potential or the potential difference between these plus ions and the electrode. So what you should have? You should have another electrode which is called a reference electrode or standard electrode. What you should have? A reference electrode. For what? In order to determine the electrode potential. So what is a reference electrode? How we can determine electrode potential? We will study one by one. So in the next class I can go, or we will study about the hydrogen electrode, which you have studied in your lower classes, that is maybe in intermediate, and we will explain how you can determine this electrode potential by using hydrogen electrode and forming a complete cell like this. These will be discussed in the next class, and until today you can go through what are the different types of electrode potentials and what are the different types of electrolytes. Means in the keywords we have covered the introduction. Similarly, what are the electrolytes and electrode potential. These three topics you can check, and if are there any doubts you can pause the video and you can recheck that one. In the next session we are going to study about how to construct hydrogen electrode and how to construct calomel electrode and how these two can be used to determine the electrode potentials. Okay, thank you.